This week we'll be looking at conducting independent factorial ANOVA analyses in SPSS. Okay, so we have our SPSS window open, and as you'll notice here we have three variables. These are the three variables that we will need to conduct our analyses today. So you'll notice that we have two categorical variables. So we have gender and hunger condition, as well as reported energy, which is measured on a interval scale. So you'll notice that for gender, we have male and female, and for hunger condition, we have hungry, satisfied, and full. And then depending on which condition people fall in, we have different levels of energy reported. So since this is an independent factorial, that means that everyone or the groups represent different people on both variables. So gender, it's independent. You have males or females, and then the hunger condition, again, it's not the same people in each group. So it looks like we have 6 people in the male hunger condition, or sorry, not 6, 8. 8 people in the male satisfied condition, 8 people in the male full condition, and the same numbers for the females in the 3 conditions. So to conduct this analysis, and sorry, as you can see once I remove the labels, these are coded with 1s and 2s, and then 1, 2, and 3. So to conduct this analysis in SPSS, it is a little bit more complex than what we've already been seeing. So first thing we need to do is click on Analyze, and then General Linear Model. So we're going to a new tab here, and then Univariate. So Analyze, General Linear Model, Univariate. We click here, we get a similar box like the ones we've been seeing, except that we do have a lot more options. For the independent factorial ANOVAs, we're just going to be worrying about these first two cells here. You don't need to worry about the rest of these. So our dependent variable is going to be our continuous or interval variable. So that's going to be our reported energy. And then the two factors, we can just put them in right here. The order doesn't matter. Okay, but this is where you put your independent variables. So we have a number of options on the side. You can skip model, you can skip contrasts. Plots is a good idea if you want to get a sense of what visually, or what the data looks like visually. So it's pretty easy to set up. We click plots, and on the horizontal axis, we typically would want the condition with more levels. So, or rather the factor with more levels. So in this case, the hunger condition variable has 3 groups and gender has only 2. So I'm going to put hunger on the horizontal axis and then gender on separate lines. If you do the invert, it's just going to flip it. It's completely correct, but personally I find it a little easier to interpret that version. So once you've selected what you would like, you need to click Add, and you should see hunger condition by gender down here, and then you can click OK. So for the post hocs, these are only going to be for our main effects. So if you recall, when we run this analysis, initially we're going to be looking at the main effect of gender and the main effect of hunger condition. However, we're also going to look at the main effect of the interaction between these two different independent variables. So if the interaction is significant, we don't need to look at the analysis of these main effects, and therefore we don't need to worry about any post hoc analyses for each of those main effects. However, if the interaction is not significant, then we would need to look at these. So we can set it up anyway. However, we may not need to use these. So when we're looking at post hocs, gender only has 2 levels, so we don't need to select any post hocs for that analysis, because if gender has a significant main effect, we already know the difference is between males and females because there is only 2 groups. And the reason we're not running a t-test on this is because we can't look at multiple variables at once in a t-test. So that's why we have to do it in ANOVA, even though that variable only has 2 levels. Now, for the hunger condition, we have more than 2 groups. So that means that even if we have a significant main effect here, we still don't exactly know where the actual differences lie. So in this case, we are going to want to select a post hoc. So you can click hunger condition here. And since we're in SPSS, we will use Chef A right there, and we can click Continue. Okay, otherwise, save nothing. Sorry, we don't need anything in there. So the last dialog box we need to select is options. And this is where we can get the different means for our group, and as well we can ask SPSS to generate the homogeneity of variance test. So I will warn you, for independent factorial ANOVAs, this test isn't very necessary if you have equal groups in each across all the conditions. So that means that you have the same number of the groups are balanced on all of your variables. So in our case they are, because we have 48 people, so we have half and half, male and female, and then we have 3 different conditions for hunger, so it's there's 12 people per condition. So or sorry, 16 people per condition. So it's not going to be an issue, but this is still where you would select it. So and also this is where you can get your descriptive statistics by all the different conditions. So if you're all the ones that you calculated by hand, you can get them to show up here. So if we just click the overall one, it's going to give us just the main information, especially on the descriptive statistic level. However, if you want to check some of the marginal means, so the ones that you had calculated, kind of the row and column means, or even the means for each cell, you can just ask SPSS to look at those by selecting these options here and moving them there, but for now we won't need to do that. Okay, from here we can click OK, and we are all set to run our analysis. Okay, so results look something like this. So first we have just the general information about the number of participants per group. So for gender, we have 2 groups, male and female, and you'll notice we have 24 people per group. And the hunger condition, again, we have 3 groups and 16 per group. So as long as you have something like this, so where the groups are equal, homogeneity of variance is not really going to be an issue. The test is rather robust. So even if Levine's is significant at this point, you won't need to worry about it. So then next we have the descriptive statistics for each cell. So now we have the mean for males, then they're hungry, the mean for males when they're satisfied, and the mean for males when they're full. And then same for the females, and then also we have the total for males, the total mean score for males, the total mean score for females, and then we actually have the total for hungry, total for satisfied, total for full, and then the overall bottom down here is the grand mean for everyone. And you can notice that the sample size is being adjusted based on which mean is being calculated. So next we have our Levine's test. So you'll notice here that it's not significant. However, if your groups are equal, it's not an issue, so you can move forward anyway. And then we have our ANOVA table. So in addition to the extra rows that we added for the for calculating the interaction, SPSS automatically adds 3 additional lines. So we have the corrected model, the intercept, the total, and the corrected total. So what you'll notice is that the corrected total is going to be similar to what you would calculate by hand, and whereas the total is takes into consideration the intercept, which we are not calculating obviously by hand. So you can ignore the corrected model, you can ignore the intercept, then you have your main effect here for gender, main effect here for hunger condition, main effect here for the interaction, and then your error term, and then skip the total line, and then it's your corrected total right here. So if we look at the analysis here, we can notice that right away all of these are significant. So, but the ones we're most interested in are the 3 right here. So we do have a main effect for gender, so that means that gender is different across the different, so males and females did respond differently according to their energy levels. And then we have the hunger condition, which means that people across the different conditions did respond differently in terms of energy levels. And then finally the hunger and the gender condition, where we looked at the interaction, and we now know that across the different cells, so not just across the 2 variables, but we have differences within the cells on reported energy. So since we have a significant interaction, we don't need to look at the main effect results. However, we will still go through that. And SPSS here also gives us a measure of the R square, which is our effect size overall. If you recall from class, I've shown you how to calculate the effect for a given main effect. So you would take the sum of squares for that effect divided by the sum of squares total. However, our SPSS automatically generates an overall effect for the entire measure. So you can report this one as an overall effect for what's being explained by all three main effects at once, so intercept, gender, and hunger, or you can calculate by hand by using this information here the main effect, or sorry, rather the effect size for just one of the main effects. Okay, so next here we have just the grand mean and the confidences around it, or confidence intervals around it. So this is just an example of some of the information that would come out when, if you recall, we selected overall in that one tab about which means to compare. If you'd select all the other ones, they would appear right here as well. But we can just skip this for now. That's just more for your information. So next we have our post hoc tests. So if you recall, we had asked SPSS to generate post hocs for our main effect of hunger condition. So since our interaction effect is significant, we don't need to interpret these because they're the main effects for each of the independent variables are not of interest. However, if the interaction effect had not been significant, you would want to look here at hunger condition and confirm whether all three groups are significantly different from one another. And as you can see here, in this case, they are. So hungry is very different than satisfied in terms of energy levels. Satisfied and full, rather. And then satisfied is very different from hungry and full. And we see the same thing here. So all of those means are significantly different. And then this is a table that automatically comes out with this test, and you can just ignore it, talking about how the variables might regroup into different groups according to what we had, but you don't. Again, you can just even delete it. Okay, and again, I can't get it to delete. That's fine. Okay, and then finally here we have our plot. So what we can see is that, okay, so both groups, so males and females, tend to not be very satisfied when they're hungry. Everyone seems to be, or sorry, not satisfied, have very much energy when they're hungry. Everyone seems to have more energy when they're hungry. And then when you look at just the males, you can see that they tend to dip a little bit when they're full, but not as much as the females. So since we have a significant interaction, we do need to look at the simple effects. So that means we need to look at whether there are differences between reported hunger for males, or sorry, reported energy level by hunger for males and females. And then we also have to look at the flip side and see whether hunger differs for males, males and females at all three conditions. So unfortunately, there's no real way to calculate the simple effects automatically in SPSS. You have to do it with a little bit of a tricky approach. So what information we do need, if you recall, is our mean square error. So if you remember, when we were calculating the simple effects by hand in SPSS, we needed to use this, not in SPSS, by hand. We used this error term to determine whether our effect was significant or not. So when we do this, we need to remember this error term because we're going to have to actually manually calculate the last part in order to report the simple effects. So just remember 0.47, and now we can close this. And actually, what we're going to do to look at this, to break this down, is we're actually going to run just simple one-way ANOVAs like we did last week, but with a split file on in order to give us the different groups. So we can close this, and then, so the first thing we need to do is activate our split file. So let's say that we do, so data, split file. So we're going to ask SPSS to sort our group by gender, which means that we'll be able to look at the main effect of hunger condition for males and females. So this is 2 of the 5 main or simple effects that we need to look at. So we can click OK. So our split file is on. Close this. And now we're going to go back to what we did last week, which is analyze, compare means, one-way ANOVA. So the split file is already on for gender. So now we're looking at hunger condition and energy. And if you recall, since hunger condition has more than 2 groups, we're going to need to ask for a post hoc test. So we can put chef A there. And then you can get the descriptive statistics. At this point, homogeneity of variance doesn't matter since we've already looked at the overall model and we're just running follow-up tests, so you don't need to select anything there. Okay, so we can click OK. And what SPSS has given us is the descriptives for each group for the males and the females. Okay, so this should match what we already saw in the main output because our group means haven't changed. But here is the important part. So these are the results of our post hoc analysis, or sorry, our simple effect analyses. So we can see that for males, when we look at whether there are any differences in reported energy levels across the 3 hunger conditions, we can see that there is a significant main effect, and the same here. However, we do need to make a slight adjustment to this value that we've reported because this is using a different error term. So this is the error term as if we hadn't run the big model, but since we have, we should recalculate this F ratio using 4.70 instead of 4.23 and 5.18. But these values are so large, we know they're still going to be significant, but if they were smaller, you would have to look up the critical value in the table using these degrees of freedom to confirm whether this is significant. But if we just open calculator here, okay, so the new F ratio for, for males for this simple effect should be 51.54 divided by 0.47 instead of 0.423. And you'll notice that it changes our value to 9.66 instead of 121. But this is still well above the critical value of F for 2 and 21 degrees of freedom. And then again, here we would need to do the same thing. So it would become 55.042 divided by 0.47. Click OK, and now we're up to 117 instead of 1.06. So again, very significant. But these are the Fs that you need to report for your simple effects and not the other ones. And then, so once we know this, we can look at our post hoc analyses. And what we can see from this is that for males, there is a significant difference between the conditions of hungry and satisfied and hungry and full. So males report significantly different levels of hunger, of energy when they are hungry versus when they are satisfied or full. However, once we look at the other groups, we notice that, okay, satisfied and full seem to be the same because this is not smaller than 0.05, but satisfied and hungry are still different. And then when we look at full, it is different than hungry and not satisfied. So what it seems here is that males, when they are hungry, respond differently, but once they're full or satisfied in terms of their food condition or their hunger condition, they are the same. Females, on the other hand, have a slightly different relationship, so we can see that they are different because everything's smaller than 0.05 across all 3 conditions. So when females are hungry, they are significantly different than when they're satisfied or full, and that holds across all 3 groups because this is smaller than 0.05. So again, if you want to know which is higher, which is lower, you could just look at the means here and you would see, okay, so these values are pretty much statistically the same. However, they're both bigger than this, whereas these values are all considered to be different. Okay, so women have the most energy when they're satisfied, the least energy when they're hungry, and then somewhere in between when they're full. Whereas males have the least energy when they're hungry, and then more energy when they're satisfied or full. Okay, so that gives us half of our simple effects. Now we need to get the other half. So we can close this, and this time go back to our split file. And then this time we're not interested in splitting by gender, we need to split by energy. So we click OK. That split file is on. And then we go back to our analyze descriptive, or general, sorry, our analyze compare means one-way ANOVA. So this time we're removing hunger conditions since our file is split by that. Actually, sorry, I just realized I accidentally split the file by energy. Go back. Sorry, that's definitely not what we want to do. We want to split the file by hunger condition. Sorry about that. Okay. Yeah, that would have been really messy if we split it that way. So now, sorry, we can go back to compare means one-way ANOVA, and this time we want to take hunger condition out and replace it with gender. And since gender only has two different categories, we don't even need to worry about post hocs this time. So you can unselect Chef A, and we know that any significant differences we see across the different conditions of hunger for gender are going to be just between male and female. So option, the descriptors are there, that's all we need, and we can click OK. So again, we have our descriptive statistics, which should match those bigger tables from the main analysis. And what we can see here is that we just have the one table, and so we are looking at the simple effects of hunger across gender, satisfied across gender, and then full. So we can see here that it looks like the only condition where we have a difference is is on the full condition, so how people respond when they're full. However, we should double check first by checking or fixing our error term here to take into account the different measure. So again, we'll take our calculator out, and so instead of having 1.563 divided by 0.563, we should do 1.563 divided by 0.47, and it goes up slightly. So now we would need to look in the ANOVA table to see whether or not this is significantly different than, or if this exceeds the critical value for 1 in 14 degrees of freedom. Okay, so we won't do that right now, but because I don't have the table handy. However, it would just be the same procedure as when you've done it by hand. Okay, so this could be close, so you'll need to look. And then same thing here. So we have 0.250 divided by 0.47 instead of 0.393. And this will definitely probably not be significant even with looking up the new table value. And then finally we have 52.56 divided by 0.47. And this will definitely still be significant for 1 in 14 degrees of freedom. So without looking in the table, we know for sure that this satisfied, there's no difference between males and females. Full, there is a difference between male and females. And to conclude about hunger, you would have to look up, or being hungry, you'd have to look up the value for 1 in 14 in the table. So that overall is how you run the independent factorial ANOVA in SPSS, and how you conduct the subsequent simple effect analyses if you have a significant interaction. If you didn't have a significant interaction, you would have stopped at just the main analysis and you would have reported the main effects. Okay, so the main effect for gender and the main effect for hunger condition. However, since we had that interaction between the two, these main effects are less interesting and we have to calculate all the simple effects. Okay, so that's it for today, and I hope that all made sense.